finished the preparation. So now we'll do it. Is from alkene and alkyne. Oxidation of alkene and alkyne So it will give you R1COH and R2COH. Right. Say, I have taken here this. It is 1, 2, 3, 4, 5. Pentene. Then 3 oxygen, H2O, CMNO4, H2SO4. Oh, you write here heat. And every time I forgot to put arrow. So this portion will give you acetic acid and this portion will give you propionic acid. So it is very easy. Don't get scared. Just use little bit of your brain, little fraction, decimal. You get here acetic acid, and here you will get propionic acid. Propionic acid. Yes, you are not able to see here now, this portion. This is 3 oxygen H2O.
No.
Because of this rain, now room is dark. So if I switch off the light, you will not be able to see. Okay, let me switch off the light and see.
So we can see.
You can see.
It's better.
Oh, good, good, good. And you have to bear my handwriting. What to do? So this is for alkene. Similarly, if I do for alkyne, the case is same only. Here also it will be 3 oxygen, H2O, MnO4, H2SO4. If you heat it, this is going to break. You will get here R1. This will be oxidized to this, and this will be oxidized to. So I'll do one more for your entrance exam. I'm always tempted to do, but I know I'm creating problem in your life. What to do? Huh? Should I do? Huh? Or I should not do? Tell me. Hello.
Yes, sir.
Okay, now see here. You remember ozonolysis? When you carry out the ozonolysis, after ozonolysis is over, then we add water and zinc. Suppose you don't add zinc, then see what will happen. See. So I'll write now here R1, see here. If I do ozonolysis of this one, this is only for your entrance exam, then you get here R1, C, R2. See, ozonolysis oxidizes only one pi bond. Another pi bond is there, na? So these two are oxidized, but this sigma bond remains. Okay, so it almost looks like a house with a roof. Now, if I add here water and zinc, see here, this will be like this, huh? This will be like this, and this will go out like this. So what happens is, you will get here this, you get here this, and you get here this, plus you get a nascent oxygen. This nascent oxygen combines with zinc. Don't write. Then you get here zinc oxide. But if I do not add zinc, what will happen? This oxygen will further oxidize this molecule. So now what is going to happen? See, I'll write here H2O plus O. What it becomes? It becomes this. Now if I break it, what do I get? 2OH. See here now. Look. One which comes here and one which comes here. It is ozonolysis of Ozonolysis of the alkynes in absence of zinc will give you this. So let me know write this intermediate. I'll write it directly write this one. Okay. So I will simply write it in this way. I'll write this one as H2O. It will give me R1 COH and R2 COH. So this I have given only for your entrance exam. Because we are always habituated with ozonolysis in presence of zinc. Here if you do not use zinc, then you get this. So if you have done ozonolysis of but1-ine, but2-ine, right here now, O3H2. See, this portion will get oxidized. What you will get? You will get acetic acid. This portion will also get oxidized to give you acetic acid. So you will get here CH2COH. This is in your syllabus. This is there in your book. But I don't know whether they have mentioned this one in your book. Ozonolysis of alkyne followed by hydrolysis in absence of zinc. Okay, done?
So wait,
Mm.
so done.
Okay. Now we'll write by oxidation of alkyl benzene, right? Preparation of aromatic carboxylic acid. Preparation of aromatic carboxylic acid by oxidation of alkyl benzene. Right. Oxidation of of alkyl benzene by acidified, this is not being given in a book, potassium dichromate or camenophore, or alkaline camenophore, gives corresponding carboxylic acid, aromatic carboxylic acid, corresponding aromatic carboxylic acid. Oxidation by alkaline cheminophore is more preferred. We do by alkaline cheminophore. All examples in your book they have given by alkaline cheminophore. Okay? So let me take this. Say I have taken here toluene. Toluene means what? Methyl benzene. Okay? So here we do oxidation. How? By cheminophore potassium hydroxide and we heat it. I told you, when you do alkaline hydrolysis, you get a potassium salt. So what you are going to get? I told you how to remember cook. So you write this. So it is potassium benzoate. You get here potassium benzoate. This is a salt. Then after that, we'll neutralize it by acid. You'll get here benzoic acid. This is there in your book. Okay. But anyway, I'll do a little further. Now, suppose you have taken 1,2-dimethylbenzene is called orthoxylene, or we call it 1,2-dimethylbenzene. This I will not do, you will do it. See, both of them will form the potassium salt. Then you will get 2 carboxylic acid. Do. The name of the acid I will tell you. Cheminophore potassium hydroxide. আমার সুবিধা নেই, সুতরাং হতে হলে বেস্ট হয়। কনসিস্টেন্সি এখানে দেখি পুরা সুইটার, এই দুটা লোয়া আমার দিনে। আর আমার তো ভিটিগনই থাকে, এটা ভিটালটা হাত পুরো দিই না, কেন লক্ষ্য দিই পুরা সুইটার। তার আমার ডিস্টার্ব হওয়ার দরকার নেই, দিনের বেলা তো দরকার নেই, বাথরুমটা করে রাত্রে বেলা পুজো জিনিস চাকরি করে। আমরা তো রাত্রে 10টার পরে ওইদিকে যাই। তার মধ্যে আমার দরকার নেই, ধর মিটিং ফিটিং থাকলে কেন কথা পার্মানেন্ট প্রবলেম সলভ। Done, finish. Yes, plus time is not there. 4 days class, if I take 8 days, then what will happen? you people. See, you'll get this. Okay? Then what you will get here? Add dilute acid. What you will get here? ময়লা পানি তোমার লিগে তো ভয় লাগে তো আসলে তো পিছলা you will get this. Okay? So this is called phthalic acid. PHALIC. You get here? Phthalic acid. Done. So all the alkyl group which is present there, they will be oxidized. All the alkyl group. Okay? Suppose it is in the para position. One is here, other is here. Then there will get terephthalic acid. Okay? Now, only remember that tertiary alkyl benzene cannot be oxidized. Okay? Right below. Note. Right. Right. Both primary and secondary alkyl benzene both primary and secondary alkyl benzene on oxidation give benzoic acid, while tertiary alkyl benzene does not undergo oxidation. MnO4 COH. We'll write here no reaction. See, this is tertiary. So no reaction. This is for your entrance. So with this, I finish the preparation of carboxylic. Nadab?
Yes, sir.
Okay. Now we'll go for physical properties. In physical properties, you hear what I say, and the summary I'll tell. So sorry, summary that I think is I'll send that from there you can read, or from the book also you can read. Okay. First one is physical state. Physical state. Okay. See, from C1 to C4. C4. These are strong pungent liquid substances. Okay. From C5 onwards, they somehow the strong smell decreases. Okay. Small decreases, and gradually it becomes white solid. Aromatic carboxylic acids are colorless substances without any smell. They do not have any smell. All right. Then let us go for solubility. Okay, solubility. It is lower member, just here. Lower member carboxylic acid are soluble in water. Why they are soluble? Because they form hydrogen bonding with water molecule. Hydrogen bonding with water molecules. How do they form? See, this is the way they form intermolecular hydrogen bonding. Because of that, they are soluble. But with increasing molecular mass, their solubility decreases. With increasing molecular mass means what? There is the length of the R is increasing. With increasing length of alkyl chain means what? Higher molecular mass. Solubility decreases. And finally become insoluble. Why? Huh? Because of the increase of hydro. Please remember, alkanes are not soluble in water. So when the length of the alkyl chain increases, their insolubility in water increases. Because this is called hydrophobic effect. Because of the increase of hydrophobic behavior of alkyl group. Oh, this one. Write this 4 lines. Write very fast.
মামা হৈ গ'ল।
আরে গুড মর্নিং, ইমান ধুনীয়াকৈ মামা কৈছো। আচ্ছা, অ'কে। You can write below. Aromatic carboxylic acids are insoluble in water. Aromatic carboxylic acids are insoluble in water except benzoic acid. Except benzoic acid, which is soluble in only in hot water.
In what?
Hot, which is soluble only in hot water. Right. It is because aromatic hydrocarbons are extremely hydrophobic in nature due to their larger size. Okay.
Sir, due to?
They are larger, LARGR, boro. Boiling point. Okay, written?
Yes, sir.
Right. Carboxylic acids have very high boiling point and is higher than most of the organic compounds with different functional groups having comparable molecular mass.
So having what?
Having comparable molecular mass, similar molecular mass. Suppose if you compare with alkanes, if you compare with alkylic halides, you compare with alcohols, aldehydes, ketones, with similar molecular mass, if you compare, carboxylic acid is going to have the highest boiling point. This question may come, right? It is because carboxylic acid molecules are very closely associated with each other through strong intermolecular hydrogen bonding.
So you're too fast.
Or is it? How come I'm fast? At this age, so I cannot move so fast. Through very strong intermolecular hydrogen bonding.
So with
Okay.
each other. So can you please repeat the sentence?
Closely associated with each other through, alright, don't write through, by very strong intermolecular hydrogen bonding. Alright? Draw this. Okay? Finish. Done.
Yes, sir.
Yes,
See,
sir.
we have seen there are many molecules which are having intermolecular hydrogen bonding, but when you boil, it goes to vapor state, they go as individual molecules. But in case of carboxylic acid, they exist as dimer. In your school, have you done the solution chapter is done? Hello? Huh?
Yes, sir.
So there, did you get one topic was there abnormal molecular mass?
Yes,
Huh?
sir.
This is because of this. Okay, now we'll go for melting point. Acha, before going for melting point, I write one more point. Because here we have compared, first we have mentioned that boiling point is very high. Second one, we have compared with the other functional group. And then write the third line, that their boiling point increases along the homologous series. Their boiling point increases along the homologous series due to the increase in their intermolecular forces of attraction,
Pardon, sir.
due to the increase in their intermolecular forces of attraction because of the increase in their sizes.
So what?
Because of the increase in their sizes. Okay, see, when the size increases, then the attraction increases. Okay. So now I will go for melting point. This one you to hear carefully. Melting point. Melting point of aliphatic carboxylic acid up to C10 shows a melting point. Like that, so an irregular trend.
So it shows.
So an irregular trend. Carboxylic acid with even number of carbon atom have higher melting point than previous and what should I say? Melting point than, okay, all right, preceding and later carboxylic acid with odd number of carbon atoms. I'll explain to you. Huh? Don't get so scared. First you write this slide. This phenomenon is known as oscillation effect, alternation effect, and commonly we call it sawtooth effect. বুঝি না তো হ্যালো মৈনাক
হ্যাঁ স্যার বলো।
হ্যাঁ ডান রিটার্ন হ্যাঁ draw the graph.
না স্যার দাঁড়াও লাস্টে একটু লিখছি।
Phenomenon is known as oscillation effect or alternation effect, or commonly known as sawtooth effect. So it almost looks like a saw, na? This is C10. This is C10. Sorry. Maskara kya? আমার ডাউরি প্রচুর জলের তো পাখি দেখি Okay, finish. Hello,
Yes.
Jadin. Finish. Okay, now see here.
Yes, sir.
See here. What is this? This is formic acid. Formic acid has one carbon. This is acetic acid, two carbon. So, actually by theory, this is propionic acid should have higher melting point than this, then we find it decreases. This is butanoic acid. Butanoic acid is higher, okay, BS. Then again you find pentanoic acid, it decreases. Why it is like this? Let us see the reason. Okay? So, we'll go for explanation. Right. You know. Right. Below. Right. The acids with even number of carbon atoms. The acids with even number of carbon atoms have trans geometry. Trans geometry and are closely packed within crystal lattice and have higher melting point. Okay? See here. Say I have taken butanoic acid. So butanoic acid geometry is this. See, this is trans. Any trans compound, they come very close to each other. In that case, the packing is very, very strong. So we'll write now here. Trans geometry. Okay? On the other hand, acids with odd number of carbon atoms have this geometry and are loosely packed within crystal lattice, resulting lower melting point. Okay, here I have written now pentanoic acid. So this is having cis. So other molecule cannot come close to it. But interestingly, this portion is missing in your textbook. This is important for your entrance exam. All books are there in your except your textbook. আমার কিন্তু আলুর ক্ষেত আছে আলুর ক্ষেত লাগাইছি আলুর ক্ষেত আলু ভালো না মেলামানটা বুঝিয়েছি আমি ঠিকঠাক যদি পর্যন্ত কমল না আমার ক্লাসের থেকে মজা করে করে না Finished?
Yes, sir.
Just see here. Let me tell you this experiment you can do at home. You take two glasses in which you drink water of similar size, or you take two bowls of similar size. Try to put one inside the other. Is it possible that bottom of one glass or bowl is going to touch the bottom of the other? Will it touch? Huh?
No, sir.
No, it will not. Because the shape of the bowl and the glass is fixed because they are in the same direction. Alright? So, any compound is having this type of geometry, they cannot come close to each other. Okay? So in that case, you will find the packing will be, their packing is going to be loose. But have you seen the egg trays? Egg trays? Huh? The paper trays are there now where people keep eggs. Have you seen?
Yes, sir.
Yes, sir.
These egg trays are having trans geometry. See, the geometries are like this. These are like this. These are all trans geometry. Because of that, see, you can keep many egg trays and you can compress them together. Is it not? Because the geometry is trans. Chengsu? Hello? The Miss from Mangap is there.
Yes, sir.
Achha.
Yes, sir.
What is the condition in your place? In Shillong, so many places we are having containment zone. In Mangap is free, na? Corona did not reach there.
Yes, sir.
Oh,
No, sir.
what reaction? I think I'll skip there. Now to online classes. I'll go and stay in your house. So from there to anywhere I can now teach. Even in future I can also and start online classes. Okay, dear. Now we'll go to the chemical property. Chemical property. Okay. So chemical properties, what I'll do? Just like your biology experiment. Now you take a flower and tear it into several pieces and you find out what are the different parts are there, and the functions are also different. It's just like that. So I'll write like this. R C O O H. See here. How many types of bond we have? We have bond between oxygen and hydrogen. We have single bond between carbon and oxygen. We have bond between carbon and oxygen, double bond is there. And this R can be alkyl or aryl. Which is the most polar group? Obviously B. So, sorry. This. All right. So, this oxygen hydrogen bond is extremely polar. So, it requires least amount of energy to break. Okay. So, you will have property. This is A. Then, property due to the breaking of carbon oxygen single bond. Then this is B. What is the third one? Property because of carbon oxygen double bond. C. What is the fourth? Fourth is the property because of entire functional group. As a whole also they are going to behave in this way. So it is D. Then you will have property because of this alkyl or aryl. So I'll write like E. Okay? So please draw. So A. I'll write property due to cleavage of oxygen hydrogen bond. But we know hydrogen will go out as H plus. So what I'll write now? Or any compound giving H plus and we call it acid. Acidic properties of B. Carbon oxygen bond will give OH group will go out as OH minus. So right now here properties due to the cleavage of carbon oxygen bond. Or put how to write nucleophilic substitution of OH group. No. Then we'll write here properties due to carbon oxygen bond. Or we'll write reduction of carboxylic or carboxylic reduction. D. Properties due to entire COH group. Then we will go for E. We'll write here now 1. Properties due to alpha hydrogen of aliphatic acid. 2. Electrophilic substitution substitution of
So
aromatic.
what's that after aliphatic?
Which one, dear? Yeah, how
So
about you? E.
E1. Yes, sir. What's that
Property
after aliphatic?
due to alpha hydrogen of aliphatic acid. And second is electrophilic substitution of aromatic acid. Finish. So tomorrow I'll start fresh with this, because if I start then again you'll forget. So up to this much is today I finish. Okay? So tomorrow we'll do.
Thank you, sir.
Tomorrow don't miss. Tomorrow I'm going to do the most important thing, factors controlling acidity of carboxylic acid. Okay? Then bye.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Yes, sir. Thank you, sir.
Thank you, sir.